The 78% token waste. AI agents communicating in natural language waste up to 78% of their throughput on politeness, redundant context, and structural filler that humans need, but machines do not. While the IEEE P3322 designation is technically an XR ergonomics spec, the industry has co-opted the term Agent Handshake to describe the critical shift away from LLM to LLM chatting toward structured protocols. The July 2026 IETF draft for the AI Agent Interoperable Protocol Framework, or AIPF, confirms that natural language is a performance bottleneck. By replacing conversational English with a three-mode state-sharing system, agents are finally moving from expensive, high-latency reasoning to direct capability discovery. This transition is less about making bots smarter and more about making their communication as lean as a standard TCP handshake. Mode 2, and the death of scraping. The recently finalized Agent Handshake Protocol, or AHP, introduces three specific operational modes that change how bots interact with the web. In Mode 1, a site publishes a machine-readable manifest of its tools, ending the era of agents blindly scraping HTML for UI elements. Mode 2 is where the efficiency gain happens. The visiting agent queries a site's local concierge instead of processing the entire page context itself. Internal benchmarks from the June 2026 reference implementation show this reduces client-side RAG overhead by a factor of 8. This isn't just a faster API. It is a mechanism that allows a site to perform its own retrieval and hand off a verified answer, bypassing the hallucination risks of an external agent trying to parse unstructured data. Verifiable Identity via A2A 1.0. Interoperability fails without trust, which is why the A2A version 1.0 standard, released in April 2026, is actually more important than the models themselves. It utilizes signed agent cards and decentralized identifiers to prove an agent's permissions and origin before a single token is exchanged. Unlike the fragmented tool calling systems of 2024, this creates a secure execution boundary. Critics argue that forcing agents into these rigid schemas limits their emergent reasoning, but the data suggests otherwise. High-stakes enterprise deployments are finding that deterministic handoffs are the only way to prevent the recursive looping errors common in multi-agent systems. When an agent transfers a task, it isn't sending a summary. It is passing a cryptographically signed state patch that the recipient can validate in milliseconds. The real implication. The emergence of structured handshakes like AIPF and A2A signifies the end of the AI agent as a person mimic and its birth as a standardized service interface. By moving communication from the non-deterministic reasoning layer of an LLM to a formal protocol layer, we are solving the three core barriers to scale: cost, reliability, and latency. The 78% reduction in token waste mentioned earlier isn't just a cost saving. It's what makes sub-second agent coordination physically possible across different organizations. For builders, this means the competitive edge is no longer in writing the perfect prompt, but in how your agent implements these capability manifests. We are shifting from an internet built for human eyes to a hidden parallel network built for machine efficiency. Watch for the August 2026 adoption of the state handoff schema by the major labs as the signal that the chat-first era of agents is officially over. Subscribe for more.